Hey, this is Donald Heslop again, dual CCIE and owner of Padlock Technologies, here bringing another session to you. Today I'm going to talk about route-based VPNs versus legacy crypto map style VPNs. This is pertaining to an FTD ASA. We're going to stay in that vein because I've already done a bunch of series about the FTD and ASA platform. So we're just going to do some comparisons, pros and cons, what I think you should do. You don't have to do it, but this is pretty much the way the industry is going. So we're going to do crypto map, and I will put legacy, because that's technically what it is now, legacy, versus route-based VPNs. All right, this is the new style, or a style that's new to the Cisco world. So crypto maps was your traditional, interesting traffic, right? Interesting traffic, right, would initiate the VPN. Then you would have, you still have your typical your phase 1 and 2 policies, right? One to secure the communication, the other one is to secure the data. And plus phase 1 actually gives you the key and material for phase 2, but I can go down the rabbit hole with that one. With route-based VPN, there is no such thing as interesting traffic. This is based on static VTIs. All right, so virtual tunnel interfaces. Now the difference is this crypto map style is not always on style VPN. All right, route-based, always on. All right, and the key here is route-based because it's in your routing. It's basically doing your traditional routing type of things. So this is always on. You can run dynamic routing protocols over it. So this is your, God forbid, RIP, EIGRP, OSPF, BGP. You cannot run, this has no capabilities of dynamic routing. The other thing, which is a key difference, because not everybody has ASAs or FTDs, is route-based style VPNs are naturally compatible with other vendors. With crypto map, depending on what you're actually doing your site-to-site tunnel to, you may run into some problems, right? And then you have to do something called proxy ID to get this to work with. When you try to do CM, which is crypto map, to a route-based site-to-site VPN, you kind of run into this proxy ID function that you need to put in here to get this to actually work. This is like FDVs or ASA going to Palo, going to Fortinet, going to, I don't remember if Checkpoint actually does that. But anything that traditionally does a site-to-site VPN, that's a route-based style VPN, you're gonna have a problem with trying to do that with your traditional route crypto map style VPNs. The other benefit is this is definitely cloud ready. Route-based style VPNs, anything from AWS, Azure, G Cloud, if you're using that. Those are going to be route-based style VPNs. They don't really do crypto map style VPNs. And again, it's the same problem if you're running a crypto map style VPN to something in the cloud that's a route-based VPN, you run into problems with that. And with route-based style VPNs, you can kind of control the routing. So a typical design that someone would do, and we're going to keep it with the FTD world, is you would have your hub, FTD, and let's say this is the hub. And then you got your spokes down here, spoke sites. Now you can actually do this in the FTD now, hub and spoke architecture. Before, this wasn't something you could do. So you could do hub and spoke architecture, and you would do route-based style VPN. Now in the hub, you would just say, don't advertise the routes. Don't advertise routes to spokes. So you don't have to worry about this happening. You don't have to worry about that happening, which is traffic going from a spoke and going straight to another spoke. You really would say this hub would be at the data center, and then they just access resources from here. All right? Everybody here accesses resources that sit behind this FTD. There's no reason for spoke to spoke like this. Spoke to spoke, the communication doesn't need to exist. If you were to do something like that, you're talking about doing a full mesh, so that, you know, if one of these things go down, one of these links go down, you can technically use another site to get to a site, but most people don't use full mesh architecture because they don't really have the need for it. Now, to do this in the crypto map style, you would basically not have this function. Everything would be a point-to-point. So this would be one point-to-point VPN, this would be another point-to-point VPN, and this would be another point-to-point VPN. And then you would be worrying about, there would be different pieces of, you know, I would say IT for instanting traffic for this tunnel, another one for this tunnel, and another one for this tunnel, right? Pain in the butt, because crypto maps are pretty much top-down processing, so you have to worry about order of operations of, hey, let me make sure I'm hitting the right crypto map sequence so that the traffic goes through. Another thing that's great about this, about route-based style VPNs, is no need for NAT, right? With crypto map VPNs, you have to NAT it. And I'm gonna say this with a grain of salt, you have to use NAT if you're also doing internet functionality on the firewall. If you're not doing internet functionality on the firewall, you technically don't need NAT, because those people should be getting, well, I would say in the RA VPN standpoint. In the RA VPN standpoint, you don't really need that, right? Site-to-site VPN really depends, right? Because it's getting encapsulated. I've done situations where I'm doing a site-to-site VPN and I'm not really sending internet traffic through there, so all I really need is the ability to get my head in to get to the other person's head in, and then once that packet gets encapsulated, I don't actually need to NAT anything. I have done that in the past, so I would say put an asterisk on you don't need NAT. It depends on your situation. RA VPN, if it's just a VPN head in and it's not doing internet traffic, you don't technically need a NAT for that either. So again, it's really based on the design. It's not really based on, it's not a hard and true, steadfast, hey, you need to do NAT every time you do site-to-site VPN. Really depends on if this is a strictly VPN head-in or it's a combination of VPN and internet and stuff like that. So based on your design will depend on whether you need NAT. Stuff like this, when it comes to this type of design, now I said which one should you use? I would say based on the pros and cons in today's infrastructure design, I would say, you know, route-based VPNs, especially if you're doing something for like hybrid cloud and you want to kind of have some security coming from the cloud. So for this picture, let's say we had cloud over here and we were doing some type of site-to-site VPN or you know, route-based VPN here, right? Since this is already cloud ready, it's nothing to go ahead and, you know, have people from this spoke, from spoke one, get resources in the cloud going through the hub, if you wanted to do that. Now this will control, you need to have your ACP to actually control this, but going through here and then going through on the back end to the cloud is something that, you know, most people do. Now a lot of people, what they will do is they'll have the FTD in front and they'll have some like express route going into the core, which is basically BGP, and then advertise into the cloud. Right, and then those routes will get propagated here. They'll use something like BGP, or they'll do BGP and maybe redistribute into like OSPF, and then OSPF will be on the route-based VPNs to the spokes, or maybe ERB to the spokes, or BGP to the spokes. Doesn't really matter. But you cannot do this type of design or topology using CryptoMap, or it's going to be really difficult you might run into a lot of problems doing this with CryptoMap style VPNs. So that's a brief discussion to talk about CryptoMap versus route-based style VPNs. If you are about to implement FTDs, are you switching over to FTDs? Are you switching over to another firewall platform? But I'm partial to FTDs. If you're trying to implement this type of solution in your environment and you're kind of stuck, don't know what to do, I'm going to leave a link in the description for a discovery call. Again, it's a discovery call. It's not a sales call. I don't really know what you're doing, so I can't really just try to sell you on the first call, right? Let's see what you're doing first before we can go to the next level. I got to see where you are before I can tell you where you need to go. It's going to be a link in the description. Let's talk at padlocktech.com. Again, that's going to go to the discovery call. Hopefully, what I showed you here will kind of give you an idea of what you should be doing in terms of your site-to-site VPNs now in this environment, not in the past. And I hope this video was informative. This is Donald from Padlock Technologies. Thank you and have a nice day.